Yes, guys. So I'm doing question number 11, in which I had done, calculated surface area we have to calculate, which was left. This was the one of the questions which were asked in this question, which was required to be solved, and the radius of the sphere. So radius of the sphere was given. What we have to find out, to find radius of the sphere, okay, radius of the sphere we have calculated 21 centimeter, and surface area of the sphere we have to calculate. The surface area is 4 pi r square, we know about, and surface area, this was the thing which was left, which we had to calculate, or which I had to calculate here, but I calculated the volume also. So let me take the volume also what's required to calculate. Okay, so that I have already calculated what the volume, what is the radius. Radius is 21 centimeter of the sphere as well as of the cone which is given here. So cone's radius is also 21 centimeter and 84 centimeter is the height of the cone given, and then this is changed into a sphere, and that sphere's radius we have to calculate. Radius and surface area of the sphere was required, but we calculated the volume also because I was in a hurry at that situation, so I didn't see what was required here, but it is here, I have written down. So let me check. Surface area was left over. What is surface area of a sphere? 4 pi r square. Okay, so substitute the value. 4 into pi, pi means 22.7 into r square. R square, radius of the sphere we have just calculated is 21 centimeter. This is 21 into 21. So 7 3 are 21. 3 into 21 is 63. And 4 into 22 is 88. So this 88 into 63, we have to finally calculate this much square centimeter or centimeter square will be the answer here. Okay, let me write here. This is, let me multiply here. This is 63 and 88. 8 3 are 24. This is 4 to carry by basic mathematics. 8 6 are 48 and 8 3 are 24. 24 and 48. 24 and 48. Because 8 6 are 48 and 8 3 are 24. The sum of these two, we have to add them. 4 plus 8 is 12, 2 1 carry, 2 plus 4 6 and 1 7, 72. And 72 plus 2 this carry. So this is 74 again, 4, 7 carry now 7 carry. Now direct multiplication, 8 6 are 48. Right, 8 6 are 48, 48 plus 7, 55. This is 55 44. This is 55 44, right, centimeter square or square centimeter. This is the area of the sphere which was changed into from cone. So cone was converted into a sphere. That sphere surface area is this. So these are the three answers. We calculate volume also. Okay, no problem. This is question number 11. Let us now talk about question number 12. What is the question number 12? Let me check that. And what is given here? That question 12, 13 and 14. There are 3 questions here now. Okay. Now question number 12. What is question number 12? What is given here? What is the total surface area? What is the total surface area of a solid hemisphere having radius equal to r, simple r. Okay, so what is given to us? Let me write here. We are given a solid hemisphere. This is solid hemisphere with radius. With the radius is small r units. Okay. To find here, what we have to find simply, we have to find what is the total surface area. Total surface area of the solid hemisphere. Total surface area, yeah, having radius equal to r. Find what is the total surface area. Total surface area. This is the required thing. As I started in the as I introduced you in the beginning, there is third formula also for a surface area of a hemisphere, which is solid one. So this area is also included. What is area of this? This is a circle. area of the circle and this half area, curved surface area, half curved surface area of the sphere. So this is half of the sphere. So whatever total surface area of the sphere was there, half of that is this curved surface area. And this top is the base. So total surface area will be this area plus this area. Curved surface area plus area of the base. So total surface area, this is solution here. So this is solid hemisphere. In solid hemisphere, this area is also included. Suppose this is the bowl here, empty bowl, or which is not having top. Then area is only the curved surface, okay, or half of the area of the sphere. Now this total surface area. So total surface area of a hemisphere is equal to curved surface. This is curved surface area, curved surface area plus area of the base, or top we can say, area of the base or top. In this case it is top. Okay, so that means this is 2 pi r square, because 4 pi r square is the area of the sphere. Half of that means 2 pi r square. This is 2 pi r square, r is the radius here, and this is radius r, small r, and this is small r, same radius. Okay, so plus area of the base is circle, so this is pi r square. This is sphere unit. So total will be 3 pi r square unit. This is the answer here. Okay, so total surface area of a solid hemisphere and empty hemisphere or hollow hemisphere are the different one. So in case of hollow hemisphere, we have only this curved surface, not the top. The top is not solid one. That area we cannot calculate. So area, curved surface area in case of hollow hemisphere or empty hemisphere. But in case of solid hemisphere, this area of the base is also added up. This is pi r square, this is 3 pi r square. This is the answer here. This is question number 12. Okay. Let us talk about now next question. Now question number 13. Let me talk about. Question number 13. Now question number 13. What is question number 13 says? 13 questions say a sphere, what is the volume of a sphere having radius equal to 3 centimeter? Okay, so this is a sphere here. What is given to us? Given a sphere. We are given a sphere with radius equal to 3 centimeter. To find here, simple, we have to find out here. What we have to find out? Volume of the sphere. What is the volume of a sphere having radius equal to 3 centimeter? Okay, so volume of the sphere of the given sphere or sphere. We have to find out the solution. Here just put the formula. We know that volume. We know that volume of a sphere. Volume of a sphere is equal to 4 by 3 pi into r cube. This is cubic, in this case unit, or but we will put here centimeters, so because this is equal to 4 by 3 into pi by 4, 22 by 7, pi is 22 by 7 into r is 3 into 3 into 3, this is 3 cube, so 3 into 3, so 1 3 cancel out, 9 4 the 36, 3 9, 9 4 the 36 into 22 divided by 7. Finally we will calculate this. This is 36 into 22, 2 6 12, 2 1 carry, 2 3 6, 6 2 12 and 6 18, 1 19, 9, 1 carry, 3 6, 6 and 1 7, 792. This is equal to 792 divided by 7, 792 upon 7. So this will give us 7 1 just 7, again 7 1 just 7, 2 remaining, 22, 7 3 are 21 and 1 remaining, then 0.1, then 3 will remain, so 37 for the 28, and in this way. This is cubic unit, centimeter cube. This is centimeter cube. Okay, so this is the final answer. How much? 113.14 centimeter cube. This is the answer. The volume of the sphere in this case, when radius is 3 centimeter, is this much. Okay, so this is the question number 13. Now let me talk about the last question, which is 14 point. Okay, so let us talk about question number 14. What does question number 14 say? Before that, let me clean this. Further, let me clean this. After cleaning the board, let me finish the last question also. Let me complete that, and then this lecture series will complete. But after that, we will take another lecture series based on the same questions, but of difficult level. In continuation, we'll continue with the next lecture series, the 19th one, which will also be based on questions on sphere and hemisphere. Alright. But before that, let me take the last question of this lecture series. This is question number 14. Let me just read it and then solve it. Now it says, a sphere circumscribes a closed cuboidal box. Very important question. This is from one of the examinations, competitive examinations. Very important question. One of the students has asked me. So it says that a sphere circumscribes a closed cuboidal box. A cuboidal box is circumscribed by a sphere. Okay. So the sphere is outside the cuboidal box. Now the sum of the lengths of all the edges of the box is 360. Okay. Maybe units of 360 units. The total surface area of the box is 5200, means 5200 or 5200 units. Find the radius of the sphere. Okay, so radius of the sphere we have to find out. What is given to us? Let me write. Here we are given a sphere. We are given a sphere which circumscribes a cuboidal box. Right, what is cuboidal box? Let me now write framed a cuboidal box. Okay, this is suppose cuboidal box. This is cuboidal box, and this cuboidal box is circumscribed by this. So what is the diameter of this? This is the diameter here. So this diameter we have to calculate, and that half of the diameter will be, what is this diameter? That means this is O center, this is AB. Okay, a cuboidal box. And what is the further things given? A closed cuboidal box. This is closed cuboidal box. Is circumscribed by a sphere. Okay, now let's say, and the sum of the edges of the cuboidal box is equal to 360. Maybe this is unit of centimeter or units. Okay, 360 centimeters or units. The total surface area and the total surface area of the box is 5200 units. square unit, because this is area, so it is the square unit. But units is not given, no problem. To find here then, it says then, what is the, to find here radius of the sphere, to find the total surface area of the box is this, and find the radius of the sphere. So to find the radius of the, this is the radius of the sphere. Radius of the sphere we have to find out. Okay, so this is the required thing. Now see here, the sphere is circumscribing the cuboidal box, which is closed cuboidal box. That is being circumscribed. Now what are the edges, some of the edges? So solution, let me find out what is given to us. It says some of the edges. Some of the edges of the cuboidal box is 360. Now try to understand. If I take, this is L, this is B, this is height H, LBH, length, breadth and height of the cuboidal box. Because we know the cuboid means length, breadth and height are different. One or two may be same, but not all the three are same. So that is cuboidal box. So length, breadth and height we have taken. So what are the sum of these? Now we see that there are four lengths. How? One length, second length and third length or fourth length. So there are four lengths. This is 4B, or 4 into L plus B plus H. L plus B plus H 4 times. Everything is 4. Why? Breadth are 4, because opposite sides, these two opposite sides are having two breadth, this breadth, this breadth and this breadth and this breadth. And the length, this length are taken the longer one, and upper wall is also, the opposite walls have four lengths. One length in the bottom, one top, other side is also having two lengths. So this is 4 times. This is 360. That means this implies that dividing by 4. So L plus B plus H is equal to 90. 4 9 36, 90. This is the first equation we are given here. From this we have calculated this. Second thing says the total surface area is 5200. Total surface area. What total surface area? The total surface area of the box is 5200. What is total surface area of the box? We know that what is LB, total surface means 6 faces we are having in a cuboid. So total area of those 6 faces will be twice bracket LB plus BH plus HL. That is the total surface area. Let me write that also. So now let me rub this whole box. Okay. So second thing given to us is total surface area. Solution we have calculated. We are finding the solution here. So this L plus B, this we have calculated. L plus B plus H equal to 90. This is first equation I have taken. And let me take the second thing. Now it says total surface area, and total surface area of the box, cuboidal box is given to us as 5200 units, or this is square unit because area is this square units. Okay, so but what is total surface area of a cuboid? We know that this is twice within bracket LB, length into breadth, area of the base and top, okay, floor and top of a room, plus BH, LB plus BH plus HL. This is a square unit. So this is equal to, we are given here the or twice LB, this is surface area. Okay, so this is, sorry, let me equate this. Or twice LB plus BH plus HL is equal to 5200. This is given to us 5200. Okay, this is second equation. We are given twice LB plus BH plus HL equal to this. Now what do we have to find out? Now it says that what is the radius? What is the radius of the sphere? Now what is the radius of the sphere? Now as I just tell you, the longest diagonal of the cuboid will represent the diameter of the sphere. Let me write here. Since the diagonal or longest diagonal, there are a number of diagonals here, but longest diagonal, and I have just discussed this in keyboard and cube, that what is the length of the diagonal or longest diagonal of a cuboid, that we know what. Since the longest diagonal of the box, cuboidal box, will be the diameter of the sphere, will be the diameter of the sphere, or what is the longest diagonal, but that is equal to square root of, we know that is equal to L square plus B square plus H square. This is value of the longest diagonal. This I discussed in keyboard. Please see that. That's a series of mine. That what is the length of the diagonal of a cuboid or a cube. If it is cube, then all the three are equal, so this will be L under root 3. But in case of cuboid, the length of the longest diagonal is under root L square plus B square plus H square. That is the value of longest diagonal. Okay, so that question is there. Now this value we have to calculate, but we are given these two values. So let me find out. This is diameter here. D is equal to, this is length of the diagonal, but this is also the diameter of the sphere. Okay, so therefore radius, let me write here. Therefore radius of the sphere, let me find out directly, will be equal to D upon 2, diagonal upon 2, equal to under root L square plus B square, because diagonal L square B square plus H square upon 2. This is the value. What is the value of this? Now let me find out this. Now I just calculated that what is twice LB plus BH plus HL plus HL equal to 5200. This is given to us. Total surface area of the cuboid is given there. What is the value of under root L square plus B square plus H square? If I take from the quadratic equations, okay, square. So this can be written as under root, can be written as L plus B plus H whole square minus 2 into LB plus BH plus HL. This is under the square root. This is the value of L square plus B square plus H square, because L plus B plus H whole square equal to L square plus B square plus H square plus twice within bracket LB plus BH plus H. So this will be cancelled out. So this is total value equal to this divided by 2. Now these two values we have just calculated. What are those values? Let me write. Under the square root, L plus B plus H is 90 here from first. This was the second one we calculated. This is 90 whole square minus, and this twice LB plus BH plus HL is 5200, and this is 5200 total value upon 2. Finally, this will give us the radius. So it is nothing but under root. Now 90 square is 8100 minus 5200 divided by 2. 2 is out of the square root. Let me now write here. Therefore R, radius of the sphere, is equal to under the square root 81 square minus 8100 minus 5200. Let me subtract here. This is 5200. Okay, 8200 minus 5200 is 0, 0. 11 minus 2, 9, and 1 carry. 8 minus 6 is 2, 2900. This is 2900 upon 2. This is the radius of the sphere which is required here. And this is 100 into 29. The square root of 100 is 10. And this is under 29, under root 29 upon 2, 2, 5 plus 10. So it is nothing but 5 under root 29. Now square root of 29 can also be calculated. This is in units. This much units are equal to. So radius of the sphere is this. 5 under root 29. Try to understand this question. Very important question. This is. We have taken this systematically. Twice LB plus BH plus HL total surface area of the cuboid was given to us 5200. Then we calculated L plus B plus H equal to 90. How? Sum of all the length, breadth and height, sum of the edges of the cuboid was given to us as 360, and that is 4 times L plus B plus H equal to 360 divided by 4 means L plus B plus H equal to 90, and that we have used here 90 square minus 50 to 100. Okay, so that by under the square root. So radius is this value 5 under 29. 29 square root can be calculated, which is 5 point something. So 5 into 5, 25 something. Let me find out square root of 29. This is 5 by 25, 4 remaining value. Okay, so 9 minus 5, 4, 0 added this 25. Okay, so 2 to the 4. If I take put here 2, that will be more than that. This is 1 only, 0.1, because if I put 2 here, that means 200 more than that. This is 1 only. So 1 1 is 1, 5 and 2 remaining value 9, 1 carry 4, and this is 149 only. Okay, so again double 0, and this is again 5.1 we can put here. This is 5.1 into 5, that means 5 into 5.1 units. That means 25.5 centimeters, or let me take units because no units is given. 25.5 centimeters or meters is the radius of this sphere required. Very important question, and this is level of difficulty is more than any other question which we have dealt with this. So this is one of the questions the student asked me. Okay, so this is very important question to understand how we have calculated length of the diagonal of a cuboid under root L square plus B square plus that square, and the value of the length of the diagonal. That diagonal will work as the diameter of the circumscribing sphere. Okay, and then we have calculated radius. Half of that diameter will be radius. Okay, so that is the question here. This is the final answer. Question number 14 is this. Okay, so this ends this lecture series. In the next lecture series, which is the 19th one, I'll talk about further questions based on sphere and hemisphere, and after that we will take fulcrum and others. Okay, and that is pyramids and prism, and then frustums of them. Okay, frustum of them is position, I mean a part of that prism and pyramids, etc. Okay, or cone, circum, that is also circular cone. Okay, sorry, right circular cones. Okay, and that is frustum of a cone, frustum of a prism or pyramid. Okay, that we will talk about, or pyramid, frustum of a pyramid. Okay, so that we will talk in the next lecture series. But next one is devoted to further in continuation of these questions, because difficulty level will be bigger than this one or harder than this one. So all those questions which are harder than these, I'll take in the next lecture series. Okay, see you in the next lecture series then. Bye.